Good morning. I had a student ask about several problems and I thought the examples would benefit everyone. So I'm going to give some pointers on a few questions on the final exam review. This one happens to be number 13 on the exam I just opened, but I think they're randomized. But it actually says a researcher is measuring water clarity, and then he does it the same time 5 years later. He immerses a weighted disc painted black and white and records when it's no longer visible. So I can click this icon to view the water clarity data. Here it is down here. And then I clicked here and opened it in StatCrunch, which you'll see over here on this side of the screen. I'm skipping to part B. It says, does the evidence suggest that the clarity of the lake is improving? And so I want to pay attention to that. If it's improving, when I come over here and look at the data, the water clarity, it would be deeper that I could see the disk. And so these numbers after 5 years would be larger. It also says let the difference be y minus x. And so I need to know which is y and which is x. So I'm going to come up here back to the question. It says let x represent the initial depth and y represent the depth 5 years later. I'm going to actually go ahead and type that in here to StatCrunch so that I remember which is x and which is y. And I'm supposed to take y minus x. So I'm taking after 5 years minus initial. And remember, these are bigger if the clarity is improving, which is what we're testing. So when I subtract them, I would be taking a bigger number minus a smaller number, and I would get something positive or greater than 0. And that's why the null hypothesis would be that the difference is 0, meaning there's no change, versus it's positive, meaning the number is larger in the y column, because when I subtract y minus x, I would get a positive number. Because I am measuring them before and after, initial and after 5 years, these measurements are dependent on one another. And so that means I'm going to use a t-stat test because I'm testing the mean, and they're paired because they're dependent. I'm going to select y for column 1 and x for column 2, only because initially the problem said the difference is y minus x. And so this difference says mu1 minus mu2, so I wanted y as sample 1 and x as sample 2. And remember, I'm testing that that second sample is larger, and I hit compute. And notice I get a p-value of 0.063. Because 0.063 is greater than 0.05, I will not reject the null hypothesis, and so it doesn't seem that there is an increased level of clarity.